Alright, so I had a little interruption and got a little messed up with what I was doing. So what I was doing is checking to see if these were extraneous, and I told you could go to your calculator, and I think this is in the video, otherwise I'm repeating myself or it's new, so bear with me for the last couple minutes. So I take the left side, put that in y1, I take the right side, the original equations, I put it in y2. I did zoom 6, and I'm trying to see if these meet at both 4 and 5. And it's a little tough to see here. So one thing I can do just to double check is I can go to my my table, and press second graph and go to if x is 4, do I get the same answer for both equations? I do. And if x is 5, do I get the same answer? So if I put 4 in the left, this is saying I should get 4 when I'm done. And if I put 4 in the other equation, I should get 4. So 4 is going to equal 4. And if I put 5 in there, x being 5, then in the first equation I should get 5 as my answer. And for the second equation, I should get 5 as my answer. So I'm just going to show you one of them by hand. So if I put, 4 in here, 9 times 4 is 36. 36 take away 20 is 16. And 16 to the 1/2 power is like the square root of 16. And I'll put 4 over here. And the square root of 16 is 4. So that's why this works. And 5 will be the same thing. So there's no extraneous solution here. So the next thing I'm going to do is, I think, number 24. That's pretty similar to it. And I'm going to get x by itself, because there's one type of x. So first I'm going to divide by 3. And that's going to give me 16 over here. And now I need to get rid of the 4/3 power. So to make this power be a first power, I'm going to take it to the 3/4 power. And in the end, what I'm doing is I'm just taking, as exponents go, 4/3 times 3 to the 4th, which gives me 12 over 12, and that's 1. So by taking this power to a 3/4 power, this is to a first power now, and I get x to the 1, or x plus 1. And that means I'm going to take this side to a 3/4 power, not 16 times 3/4, it's 16 to the 3/4 power. You can type that in your calculator, but again, we did this in the first page. I can just rewrite this, and what your calculator will be doing is taking the 4th root of 16, that is 2, and 2 to the 3rd power, and getting 8. Now if I think about it, and this is one I could see that you leave out, that we're taking an even root. So if you realize that you can also take the 4th root of 16 and get -2, and then -2 to the 3rd power and get -8, that's fantastic. I think this is one that you might not notice that on as much. So, just be careful of that. Anyway, I will be getting 2 answers, because I'm going to take x plus 1 with 8 and x plus 1 with -8. And when I subtract 1 from this, I get 7. But when I subtract 1 from this, I'll get a totally different answer. I'll get -9. So don't do 7 and then think the other one's -7. So is this extraneous? In the original problem, because we'll be taking a cube root, technically, you don't have to worry about this. Alright, so the next couple problems that I'm going to deal with are the square root ones and cube root ones. So when you have the radicals, your job is to isolate the radical. Here my radical is already isolated, so to get rid of the square root, I'm going to square both sides. The square gets rid of the little check mark, and then on this side I'll have x squared. And now that I have more than one type of x, I'll be getting x by itself, so I'm going to, in order to make it easy factoring, leave this positive and move the x and the 42 over. And then I'll try for factoring. So factors of -42 that get me to -1, there is a set. It's 6 and 7. I'll make the 7 negative. And now I can do x plus 6 and x minus 7. And when I set them equal to 0, I get -6 and 7 is my answer. What we want to see is, because we have a square root, are either of these extraneous. So first I'll put 7 in. So 7 on the left, 7 on the right. Put 7 over here, 7 plus 42, that's 49. If I take the square root of 49, do I get the 7 that's on the right side? You do. So 7 works. And if I put negative 6 in, so negative 6 plus 42 is 36. If I take the square root of 36, do I get negative 6? Remember, we are not solving anymore. This is just put the number in the calculator. Do you get the number that's on the right? You don't. So negative 6 is not a solution. It is an extraneous solution. The only solution to this is 7. And again, this is a really good one to see on the calculator. I would put the left side in. I would put the right side in. Zoom 6. And do these meet at negative 6 and 7? There's the left side. There's the square root. Here's the right side. You're going to see that, I mean, this x value is 7. Negative 6 is over here, and they're never meeting. So that's the other way you can tell. So number 20. Again, I need to isolate the radical. It already is. So to get rid of the radical now, I'm going to square both sides. That gets rid of the check mark. And this I'm going to have to remember that x plus 3 squared means there's 2 of them. So when these neighbors meet, I get x squared and 3x. And then these neighbors meet, I get another 3x and a 9. So I can turn this into x squared and 6x and 9. So now because of one type of x, I'm going to go for factoring. That means I got to get everything to one side. I want to leave that positive in case easy factoring works. So the 2x will join the 6x. That's 4x. The 6 will join the 9. That's 3. So when you're done, factors of 3 that get you to 4, it works. You get 3 and 1. And now I can go for x plus 3 and x plus 1. And now I'm going to solve for x. I get negative 3 and negative 1. So do these both work? We're going to go with the graphing calculator option this time. So on the left side, I'm going to put the square root of 2x plus 6. On the right side, I'm going to put an x plus 3. I'm going to zoom 6 it. Again, you can pause, stop, rewind, all that stuff. So there's the left side. Here's the right side. So it's only meeting at one spot. So does that look like more like it's, what were the numbers, negative 1 or negative 3? Well, there is x is negative 3. And there's negative 1. Are they meeting at negative 3? That's a little tough to tell. So I'm going to go to my table. I'm going to go up to negative 1. So if x is negative 1, on the left side of the equation I'd get 2, and on the right side of the equation I'd get 2. So negative 1 works. If negative 3 goes in, then on the left side, if I did the math, I'd get 0, and on the right side, I'd get 0. So these both work. Okay? Next one, solving for x, isolate the radical. It's isolated. I'm going to square both sides. And that gives me 16. There's just one type of x. Get x by itself, move it over, and you get 15. So for this one, I'm going to check by hand. If I put 15 back in here, does it work? 15 plus 1 is 16. The square root of 16 is 4. This works. Next one, so 23. I know there's a lot of problems. So to get rid of a cube root, the radical has already been isolated. I'm going to cube both sides. So I'm going to get x minus 7, cube the side, not times 3. That's 27. Add 7, and I'm going to get 34. So does 34 work? 34 take away 7 is 27. The cubed root of 27 is 3. This works. Again, the only problems that you have to really check for extraneous solutions are the checkmark problems, the radicals. All right. Whoops, sorry. I keep hitting that thing. There's more. Oh my God, yeah, there's more. But these will go pretty fast. So we got this equation here. It says biologists have discovered that the shoulder height of a male Asian elephant can be modeled by this equation. H is the height, and then T is the age in years. So determine the age. We'll have to figure out what T is if H is 220. So I'm putting 220 in for H. And now I'm going to get t by itself. There's just one type of t. So first I'm going to subtract this 75.8 over. So I got my calculator off to the side. That gives me 144.2 when I subtract. By the way, I am doing order of operations backwards. I moved my addition, subtraction. Now I'm going to move the multiplication. This is multiplying to this, so I'm dividing by this. And don't be afraid by the decimals. That's why we have our calculator. So I'm going to take the 144.2 and divide it by the 62.5. And I get a longer decimal. And now I'm going to get rid of the exponent. And to get rid of a 1/3 power, I will need to use an exponent that is the reciprocal. So when I take 1/3 to the 3rd power, I am multiplying the exponents. That's 3 over 3. And now t is to a 1st power. But that means I'm going to take this side to the 3rd power, not times 3 to the 3rd power. So I'm going to take my answer to the 3rd power, and I get this 12.28. And it does not say how to round, so I'm just going to say 12.28. All right, next one. When a rock is dropped from a cliff on the face of the earth, the elapsed time, t seconds after it's fallen, so many meters, d is the distance it's fallen. Here's the equation. So determine the elapsed time. So we're going to figure out t if it's dropped 40 meters. So here we go. Just put the numbers in the right spot. It's dropping 40 meters. And look, this is just a bunch of numbers. I just have to go to my calculator and type that in. So you'll see it in just a second. I'm going to type it in exactly as I've written it. And a 1/2 power is a 0.5. Let the calculator do all the work, and I'm going to get 2.86. I'm going to round everything to the nearest hundredths. So how far has a rock dropped? So what is that distance it's dropped if 3 seconds have gone by? So I'm going to put 3 in. And again, that's a 1/2 power. That doesn't look very good. I got to get d alone. It's just one type of d, so I'm doing this PEMDAS backwards. First, there's no addition subtraction, so I'm going to move this. This is multiplying to this, so I'm going to divide. So on my calculator, I'm typing in 3 divided by 0.452. Dividing. So over here, I got about 6.64. Notice it's all in the calculator. And now to get rid of the 1/2 power, to get rid of that exponent, I'm going to take it to the 2nd power. Because I'll multiply the exponents, that just gives me d, and then I'm going to come to this side and get the 1/2 power. So one option is I can just square it, and I'll take my answer and square it. Or I could do 6.64 and square it, and you're not going to see much of a difference. Not enough. 44.05, 44.09, whichever one you want to write down. Technically, the 05 is a little more accurate, so that's the one I'm going to write down. Last problem. Oh, my goodness, let's hope we get this done. All right, here we go. Last problem.